We're going to be finding the area of a regular polygon. This isn't really its own section, but it needs to be taught separately. So we're going to be looking for area of a regular polygon. Remember, regular polygons have all angles that are equal and all sides that are equal. One thing you need to know about a regular polygon is that it has what's called an apothem. It's sort of like an altitude, and I'll highlight it for you right now in yellow. It's this area right there, that dotted line drawn down at a right angle. So it's just like an altitude or a height, and it's called an apothem in a regular polygon. And the other thing that you need to know is a central angle. A central angle is basically all of these angles in the center. So if I want to know what one of those are, well, think about it. A circle is 360 degrees, so it's really 360 divided by the number of angles or the number of sides there are. So 1, 2, 3, 4, 5. This is a pentagon, so we would divide that by 5. So these are all 72 degrees. All of the central angles for this pentagon are 72 degrees. And now you need to know the formula of an apothem, to find the area of a regular polygon, which is right here for you. Let's try to keep all that in there. So the area of a regular polygon, I'll highlight it in blue. It's A equals 1/2 lowercase a capital P. So now these capitals matter. The capital A stands for area. So the area is equal to 1/2 times, the lowercase a is the apothem, and the capital P is the perimeter. And sometimes you need special right triangles or trigonometry to help you to find missing side lengths or missing angles in this case. Okay, here's our first example. So we always start with our formula. I know that I'm looking for the area, so it's going to be 1/2 lowercase a capital P. So area equals 1/2. I see my apothem is 3 radical 3. It tells me that. And the perimeter, well, that's going to be 6 for each side. So 6 times 1, 2, 3, 4, 5, 6 sides. This is a hexagon. So 6 times 6, which is 36 meters. All right, and then the area is equal to, that was also meters, so it's going to be meters squared still since it's area. And you can multiply what's convenient first. So if I want to do half of 36 first and get 18, I can do that. And then 18 times 3, which is 54 radical 3. So remember, you can only multiply those outside numbers together, and then put the radical 3 at the end. And that's going to be meters squared. Okay, to find the area of this one, we have A equals 1/2 times the apothem times the perimeter. So we have 1/2 times, we don't know the apothem at the moment, but we can figure out the perimeter actually, because we know that one piece is 4, 1/2 of it, one side is 4. So that means that each side length is 8, and there are 5 side lengths if it's a pentagon, so 8 times 5 is 40. So I'm going to need to do some work to be able to figure out the apothem. But I do have my 36. Let's pull out this right triangle that we have that they're kind of focusing on there. So here's my right triangle. This is 4. The angle's 36. So what could I use to find this lowercase a? So if you look at the angle that was provided and look across from that, opposite is 4. And adjacent is A. So opposite and adjacent, that would be tangent. So tan 36 is equal to opposite 4 over adjacent. So when I calculated 4 divided by tan 36, I got A equals 5.51 inches. So now I can put that in, 5.51, and I can take half of whatever I want to take first. It'd be easier to take half of 40, so that's 20 times 5.51, which results in the area of 110.2 inches squared. There's not always going to be a picture drawn for you, so sometimes you might have to draw a picture. This is asking for area of a regular octagon, so again, 1/2 times A times capital P, and it gives you a side length. It says that it's 4 centimeters, so if you have an octagon and each side is 4 centimeters, it's 8 times 4 for a perimeter of 32 centimeters. 1/2 times, we're missing the apothem again. So if you picture that octagon, what I only actually care about, there, it gives you a rough idea. What I only care about is the fact that one side is 4 centimeters, and I'm going to be taking half of that side, which is 2 centimeters. So let me draw out my right triangle. I need half of the side for my right triangle, and this is always going to be 1/2 of the central angle. So I can calculate the central angle. So remember, to find central angle, I'm going to do 360 divided by the number of sides. And that's 45 degrees, but I need to cut that in half since I just took half of the central angle. This would have been the whole central angle, and I'm cutting it in half just for the right triangle. So I need 22.5 degrees there. So I'm going to be taking, for the apothem, it's going to be tangent of 22.5 is equal to opposite 2 over the apothem A. And so when I calculate, I'm going to end up doing 2 divided by tan 22.5 and get that A is 4.83. So now I can plug that in. A equals 1/2 times 4.83 times 32, which is really like 16 times 4.83. 77.28 centimeters squared is the final area. For the now you try, we have an equilateral triangle. So we know that everything is actually 60 degrees already. It's equilateral. And we're going to be drawing, so from the center, our apothem is 2 feet. And our central angle, we would have had 360 divided by 3, which is 120, and we cut that in half because we only need half of it, so it's a 60. So if my apothem is 2, and this is a 60 right here, then 2 is across from 30, which is S, and across from 60 is S radical 3, so that would be 2 radical 3. So I used a special right triangle there to figure that out. And then I can figure out my area, so if only 1/2 is 2 radical 3, then this whole bottom piece is 2 of those, which is 4 radical 3. And then the triangle has 3 sides. So if you do 4 radical 3 and 4 radical 3 and 4 radical 3, or just multiply by 3, you'll get 12 radical 3 for the perimeter. So this is what I have. Area equals 1/2 times my apothem, which was given, that was 2, and what I calculated was 12 radical 3 using special right triangles. And if you don't remember special right triangles, I could have just done like tangent of 60 is equal to opposite, which was my x, over 2. And I could solve that way, I'd get the same answer. So anyway, half of 2 is 1, so A is going to be equal to 12 radical 3 times 1, which is 12 radical 3 feet squared. Okay, and the next one we have a regular dodecagon that's 12 sides with a side length of 5. So I already know that the perimeter is 60. So A equals 1/2 small a times the perimeter of 60 meters. And I'm going to draw out my right triangle that would have come out of the dodecagon. So this is actually half of 5, which is 2.5 meters. And the central angle, remember, is 360 divided by the 12 sides, which is going to be 30. 330, and then cut that in half, which is 15 degrees. It's always half of the central angle right there. So we have tangent of 15 is equal to opposite 2.5 over the adjacent, which is the apothem. So let's calculate that. It would be 2.5 divided by tan 15. So A is 9.33. So now I can plug that in. A equals 1/2 times 9.33 times 60, and half of 60 is 30, so I'm essentially doing 30 times 9.33. Area equals 279.9 meters squared.